forget originality. In the unforgiving calculus of military hardware, innovation is a currency spent only when imitation and iteration will not suffice. The laws of aerodynamics are universal, the chemistry of an explosion is immutable, and the geometry of a survivable tandem-seat cockpit is a problem solved through decades of brutal, expensive trial and error. To look at the emerging AVIC Z-21 and see only a facsimile of an American Apache is to miss the point entirely. This is not a design competition, it is a final exam, and China has shown its work. The Z-21 is the inevitable result of a nation with a colossal budget, a clear strategic imperative, and a complete lack of sentimentality about borrowing proven concepts. It is the answer to a question the People's Liberation Army, PLA, has been asking for years: how to build a machine that can survive the opening minutes of a high-intensity war and kill the enemy's most expensive assets. This helicopter is a statement of industrial arrival, a declaration that the era of playing catch-up is over, and a clear signal that from now on, the apex predators of the sky will no longer be an exclusive club. Subscribe to the channel so you don't miss new analytical reviews. The genesis of the Z-21 lies in a strategic void that became increasingly untenable for the PLA. While the Changhe Z-10, known within the PLA by the suitably dramatic moniker Fierce Thunderbolt, is a capable medium-weight attack helicopter, its inherent limitations in payload, operational range, and survivability became glaringly apparent as China's strategic horizons expanded. The Z-10, a machine in the 5.5 to 7-ton class, was a significant step forward from armed utility helicopters, but it was never a peer to the 10-ton behemoths like the American AH-64 Apache or the Russian Mi-28 Havoc. In any potential high-intensity conflict, whether in the Taiwan Strait or along the high-altitude frontier with India, the PLA required a platform that could carry a heavier punch, endure more punishment, and operate effectively in the most demanding environments. This necessity gave birth to a design philosophy officially termed heritage and innovation, a piece of state-sponsored marketing that neatly encapsulates a deeply pragmatic engineering decision. Rather than embarking on a decade-long high-risk development program for an entirely new airframe, designers at Harbin Aircraft Industry Group and Changhe Aircraft Industries, the respective parents of the Z-20 Transport and Z-10 Attacker, turned to a proven foundation, the Z-20 utility helicopter. This platform, itself a well-executed and domestically evolved derivative of the Sikorsky S-70 UH-60 Black Hawk airframe that China acquired in the 1980s, provided a mature, reliable, and indigenously produced chassis. The result was less a new creation and more a sophisticated transplant, a kind of arranged marriage between a sturdy, dependable transport and a nascent predator. This approach, leveraging the Z-20's established power plant, 5-bladed main rotor system, transmission, and entire tail assembly, was a masterstroke of risk mitigation and timeline acceleration. The commonality of these critical dynamic components not only slashed development time, making a projected service entry of 2027-2028 feasible, but it also promised to dramatically streamline logistics, maintenance training, and spare parts inventories for the PLA's ground crews. This developmental model is a microcosm of China's broader military modernization strategy. It is not about reinventing every wheel, but about rapidly absorbing, iterating, and integrating existing technologies to achieve near-peer status in critical domains, prioritizing speed and sufficiency to meet the ambitious timelines set forth by the Central Military Commission. The anatomy of the Z-21 is a testament to this hybrid philosophy. From the tail boom forward, the machine is a purpose-built weapon of war, but its lineage is unmistakable. While the empennage, with its slab-like, unswept horizontal stabilizer and tail rotor assembly, is almost a direct carryover from the Z-20, the rest of the airframe has been radically reshaped. The wide, troop-carrying cabin of the utility helicopter has been replaced by a new, slender fuselage designed around a tandem, stepped cockpit that seats a gunner in the front and a pilot in the raised rear position, a configuration that has been the global standard for attack helicopters for half a century for its optimization of visibility and crew protection. The cockpit canopy itself, with its flat-panel angular design, bears a striking resemblance to that of the AH-64, likely constructed from multi-layered ballistic-rated glass to protect the crew. The most visually distinctive and telling feature, however, is the pair of large, boxy cheek fairings that run from the nose along the sides of the fuselage, terminating at the tail boom. Far from being an aesthetic flourish, these fairings are a critical design choice, borrowed directly from the AH-64DE playbook. They provide the necessary internal volume to house a vast suite of avionics, ammunition feeds for the chin-mounted cannon, and potentially additional fuel storage, all while adding a significant layer of lateral protection for the cockpit. The airframe itself is undoubtedly a modern mix of aluminum alloys and advanced composite materials to manage weight without sacrificing structural integrity, a practice well established in China's aviation industry. It is highly probable that critical areas such as the cockpit tub, engine nacelles, and transmission housing are further protected by advanced composite armor, perhaps even incorporating the applique graphene armor plates seen on later production Z-10s to improve ballistic protection against small arms and cannon fire. The entire structure is built with survivability as a core principle. This is not a stealth helicopter in the vein of the canceled American RAH-66 Comanche, but it incorporates significant signature reduction measures learned over the past 2 decades. The most obvious of these are the prominent upward-facing engine exhausts, which are designed to vent hot gases directly into the turbulent downwash of the main rotor. This simple but effective technique scatters the helicopter's thermal signature, making it a much more difficult target for heat-seeking man-portable air defense systems, MANPADS. The fuselage also employs canted surfaces and blended wing-body junctions to minimize its radar cross-section from the frontal aspect, lessons clearly learned from the Z-10 program. This comprehensive, multi-layered approach to survivability, combining armor, infrared suppression, and a sophisticated electronic warfare suite, points to a machine designed with a specific high-threat environment in mind, the lethal, saturated battle space of the opening hours of an amphibious assault, likely against Taiwan. It is a platform built to penetrate a modern, dense integrated air defense network, absorb punishment, and survive to continue the fight, a clear doctrinal response to lessons observed in the heavy attrition suffered by even advanced Russian helicopters like the Ka-52 in the early phases of the war in Ukraine. At the heart of this predator are 2 domestically produced WZ-10 turboshaft engines, the same powerful family that propels the Z-20 transport. Each engine is rated to produce between 1,600 and 2,000 kilowatts, translating to a formidable 2,100 to 2,700 shaft horsepower, with some reports suggesting a specific uprated variant for the Z-21 producing around 1,690 kilobars, 2,400 HP. This immense power output, totaling nearly 5,000 SAP, is essential for a machine in the 10-ton maximum takeoff weight class to lift a heavy combat load, maneuver aggressively, and perform effectively in the challenging hot and high conditions that define many of China's strategic frontiers. However, as any seasoned aeronautical engineer would attest with a wry smile, simply bolting powerful engines to an airframe is the easy part. The true black magic of helicopter design, the component that separates a successful platform from a catastrophic failure, lies in the main transmission. This complex assembly of gears and shafts must reliably channel the combined torque of 2 powerful turbines into the rotor mast without disintegrating. The United States Army and its contractors spent years and vast sums of money perfecting the advanced face gear transmission for the AH-64E to handle the increased power of its new engines. China's ability to design and mass-produce a transmission that can withstand the colossal forces involved in the Z-21's powertrain will be the ultimate litmus test of its advanced manufacturing, metallurgy, and precision engineering capabilities. It is the sort of unglamorous internal component that never appears in propaganda videos, but single-handedly determines whether the officially christened airborne war deity can actually live up to its name or simply vibrates itself into a pile of expensive scrap on the flight line. This power is delivered to the Z-20's proven 5-bladed main rotor, a modern composite design with swept-back tips that enhance aerodynamic efficiency, reduce the acoustic signature, and provide greater lift and a smoother ride compared to the 4-bladed systems on the Apache and Mi-28. This entire dynamic system is particularly optimized for high-altitude performance, a key design driver that addresses a major shortcoming of the Z-10. The extensive and well-documented flight testing of Z-21 prototypes on the Qinghai Tibet Plateau at altitudes exceeding 4,000 meters confirms its intended role for the PLA's Western Theater Command along the mountainous border with India. In the thin air of the Himalayas, the surplus power generated by the WZ-10 engines is not a luxury but a necessity, providing the critical margin needed to maintain lift and maneuverability while carrying a full complement of fuel and weapons. With a projected service ceiling similar to the Z-20's 6,000 meters and an estimated top speed of around 350 kilometers per hour, the Z-21 is positioned to perform on par with, or in some cases exceed, the kinematic capabilities of its international rivals. To employ its formidable performance, the Z-21 is equipped with a suite of advanced sensors and a lethal arsenal that represent the pinnacle of China's current avionics and munitions technology. The crew operates from a modern glass cockpit, featuring large multifunction displays and helmet-mounted display and sighting systems, HMDSS, that project critical flight and targeting information directly onto their visors, enabling heads-up operation. The fly-by-wire flight control system, inherited from the Z-20, reduces pilot workload and enhances maneuverability. The helicopter's eyes consist of a multi-sensor package designed for all-weather, day-night operations. A prominent turret mounted under the nose houses high-resolution electro-optical, daylight TV, and forward-looking infrared, FLIR sensors for target detection, identification, and designation. The most significant sensor, however, is the anticipated mast-mounted fire control radar. While not visible on all prototypes, its inclusion on production models is considered a certainty and is crucial for the helicopter's intended role. This millimeter-wave MMW radar, conceptually analogous to the AN/APG-78 longbow on the Apache, would grant the Z-21 the ability to detect, classify, and engage multiple targets from a concealed, hull-down position behind terrain, providing a true fire-and-forget capability that dramatically enhances both lethality and survivability. This sophisticated sensor suite is protected by an equally comprehensive electronic warfare (EW) package. The airframe is bristling with an array of antennas and apertures that indicate a 360-degree, fully integrated self-protection system. This includes radar warning receivers, RWR, to detect enemy radar emissions, laser warning receivers, LWR, to alert the crew to laser designation, and missile approach warning systems, MAWs, to detect the heat signature of incoming missiles, all of which are networked to automatically deploy countermeasures from chaff and flare dispensers. The Z-21's claws are equally impressive. An under-fuselage automatic cannon, likely a 23mm or 30mm weapon, will provide suppressive fire capability, and while absent on early test beds, its mounting point is clearly visible. The primary offensive power resides on the stub wings, which feature at least 6 hardpoints for a heavy and flexible weapons load. The key capability and the entire justification for a helicopter of this size is its reported capacity to carry up to 16 anti-tank guided missiles, ATGM. These would include the proven laser-guided AKD-10 and likely a newer generation of MMW radar-guided missiles designed to work in conjunction with the mast-mounted radar. For self-defense against aerial threats, it will carry the TY-90 infrared-guided air-to-air missile, and for engaging softer targets, it can be armed with pods of unguided rockets. This combination of a mast-mounted radar and a massive missile loadout is not merely about matching the Apache's specifications on paper. It enables a specific PLA combat doctrine centered on massed standoff fires. One can envision Z-21s operating in hunter-killer teams, where a single helicopter uses its elevated radar to acquire and designate targets for several other Z-21s lurking behind cover. This would allow a flight of 4 helicopters to launch a coordinated salvo of up to 64 ATGMs almost simultaneously, a volume of fire designed specifically to overwhelm and saturate the active protection systems, APS, that are becoming standard on modern main battle tanks. In the global pantheon of attack helicopters, the Z-21 arrives as a serious contender, a machine whose design reflects a careful study of the world's leading platforms. When compared to the Boeing AH-64E Apache Guardian, the Z-21 is a direct answer, mimicking its general configuration, heavy missile payload, and the crucial mast-mounted radar concept. The Z-21's 5-bladed rotor may offer a smoother flight profile, and its design appears more explicitly optimized for high-altitude operations. However, the Apache's paramount advantages remain its decades of combat-proven performance, unparalleled reliability, and its deep integration into the U.S. military's network-centric warfare architecture, including the mature ability to directly control unmanned aerial systems, MUM-T, a capability China is developing but has yet to field on the same scale. Against the Russian MIL Mi-28NM Havoc, the Z-21 presents a different contrast. The Mi-28 is renowned as a heavily armored flying tank, built for ruggedness and close-in combat. The Z-21, much like the Apache, appears to prioritize its role as a sophisticated sensor and weapons platform over sheer brute force, betting on standoff engagement and superior situational awareness for survival. While both carry heavy armament, the Z-21's anticipated domestic electronics and MMW radar may give it a generational advantage over some Russian systems. The other premier Russian design, the Kamov Ka-52 Alligator, is an outlier with its unique coaxial rotor system that provides exceptional agility and a high top speed, but at the cost of greater mechanical complexity. The Z-21's conventional lower-risk design reflects China's more conservative engineering approach. The PLA's doctrine for the Z-21 will see it employed as a first-wave asset in its most critical scenarios. In a potential invasion of Taiwan, Z-21s would launch from amphibious assault ships like the Type 075 or from mainland bases to suppress beach defenses, hunt Taiwanese armor, and provide armed escort for landing craft. Along the Indian border, its superior high-altitude performance makes it the ideal platform for providing decisive anti-armor firepower in the thin air of the Himalayas. In the South China Sea, operating from island bases or naval vessels, it would serve as a long-range armed reconnaissance and maritime strike asset, capable of enforcing China's territorial claims. Ultimately, the AVIC Z-21 is far more than just a new helicopter. It is a capstone project for China's rotary wing industry and a powerful symbol of its military-industrial evolution. It demonstrates a mature capability to not only reverse engineer and replicate, but to synthesize, adapt, and integrate complex systems into a new, formidable platform that fills the PLA's last major gap in conventional Army aviation. The Z-21 is the product of a system that can now produce military hardware broadly comparable to the world's leading powers. Its likely modular design will facilitate a clear path for future modernization, including the integration of more powerful engines, enhanced sensors, full drone control capabilities, and deep networking within the PLA's future intelligentized warfare system. Once it reaches maturity and enters full-scale production, it is almost certain that an export variant, perhaps designated the Z-21ME, will be offered on the international market. This will present a cost-competitive, politically unconstrained alternative to the Apache and Havoc, challenging the long-standing duopoly of American and Russian suppliers in the lucrative heavy attack helicopter market and serving as another potent tool of Chinese foreign policy and strategic influence. The shadow cast by this new dragon will, therefore, extend far beyond the contested coastlines and high-altitude battlefields for which it was forged. If the Z-21 is the answer to a technical challenge, it is also the embodiment of a much larger geopolitical transformation. The helicopter does not exist in a vacuum. It is both a product and an instrument of China's broader strategy to rewrite the military balance of power in Asia. Its development cannot be disentangled from Beijing's persistent pursuit of world-class armed forces by 2049, a centennial benchmark the Communist Party repeats with ritualistic precision. The arrival of the Z-21 signifies more than tactical utility. It is a message to regional adversaries, to global suppliers of high-end defense products, and to the international arms market that China has stepped fully into the realm of heavyweight military aviation producers. Within the structure of the People's Liberation Army Ground Force, the Z-21 will serve as the high-end complement to the Z-10, forming a two-tiered attack helicopter force. The Z-10, lighter and more numerous, provides mass and affordability, while the Z-21 represents concentrated lethality, survivability, and high-value strike power. This dual approach mirrors the PLA Air Force's own tiered modernization, where fourth-generation fighters like the J-10 still fly alongside the more advanced J-20 stealth fighters. Such layered modernization allows China to project credible strength across a spectrum of missions while controlling costs and production bottlenecks. The Z-21's doctrinal employment will likely follow an echeloned concept of operations. First-wave Z-21 formations will penetrate defended zones, using radar-guided munitions and long-range ATGMs to dismantle armored spearheads or destroy forward-deployed artillery. The more numerous Z-10s would then sweep in to exploit the breaches, engaging less well-defended units and providing close support to mechanized forces. This Hunter Elite Plus Pack model is designed to maximize the efficiency of China's rotary wing fleet while ensuring that its most advanced helicopters are committed where their survivability and specialized sensors provide decisive leverage. Equally important is the integration of the Z-21 into China's evolving system of systems warfare doctrine. The PLA does not view helicopters as isolated assets. They are nodes in a dense, multi-domain network. The Z-21 will feed and receive targeting data from satellites, UAVs, ground-based sensors, and long-range artillery units. In practice, this means that a Z-21 gunner may not even be responsible for finding his target. The helicopter may merely act as the final shooter in a kill chain that begins with a drone swarm or an over-the-horizon radar. This network-centric philosophy echoes American doctrine, but is being tailored for China's geography and strategic priorities, with a heavy emphasis on saturating adversary defenses through redundancy and mass. One cannot underestimate the export potential of the Z-21. For decades, the global heavy attack helicopter market has been effectively monopolized by the United States and Russia. Nations seeking an advanced high-payload platform have had to choose between the Apache and the Havoc, both of which come with steep costs and, in the case of the Apache, political conditions dictated by Washington. The Z-21 promises to break this duopoly. China's approach to arms sales has always been transactional and politically flexible. Countries barred from acquiring Western systems, such as Iran, Pakistan, or certain African states, could suddenly find themselves with access to a heavy, radar-equipped gunship at a fraction of the cost of an Apache. The designation Z-21ME is not yet official, but the pattern is clear. Just as the Z-10ME has been marketed as an export-optimized variant, so too will the Z-21 follow this path. The appeal will not only lie in price, but also in availability. China has demonstrated a willingness to deliver weapons quickly and without the political strings that accompany American foreign military sales contracts. For China's aviation industry, the Z-21 represents a technological watershed. To bring such a machine from concept to field trials within a decade reflects enormous strides in materials science, computer-aided design, avionics miniaturization, and, crucially, the industrial discipline needed to mass-produce complex gearboxes and composite rotor blades. Each successful Z-21 that rolls off the assembly line is a quiet repudiation of the assumption that China cannot innovate in high-end aerospace. Even if much of the design DNA is borrowed, the act of synthesis itself, turning disparate inspirations into a coherent working combat platform, is a form of innovation. For Taiwan, the Z-21 is a nightmare in waiting. The island's defense strategy is built upon inflicting unacceptable losses during the first days of an invasion, buying time for outside assistance to arrive. Attack helicopters are particularly lethal in this window. Operating from Type 075 amphibious assault ships or coastal FOBs, Z-21s could sweep ahead of landing craft, suppressing coastal artillery, obliterating armored counterattack forces, and cutting off mobile reserves. With a mast-mounted radar granting them the ability to fire from behind ridgelines, Taiwanese defenders would face a stealthier, more survivable predator than anything China has fielded before. Along the Himalayan frontier with India, the implications are equally significant. India's own attack helicopter fleet, centered on the AH-64E Apache and the domestically developed light combat helicopter, is tailored for high-altitude performance. Yet the Z-21, with its proven testing above 4,000 meters, represents a direct challenge. The battle for dominance in the thin air of Ladakh or Arunachal Pradesh would pit these machines in a contest where payload margins, engine efficiency, and sensor superiority could determine who holds the ridgelines. The Z-21's presence forces India to confront the possibility of parity, or even inferiority, in a domain where it has traditionally enjoyed technological confidence. In the South China Sea, the Z-21 introduces a rotary-wing dimension to China's militarization of artificial islands. Armed with anti-ship missiles or long-range ATGMs repurposed for littoral strike, it could provide overwatch for amphibious landings on disputed reefs or serve as a flexible maritime denial asset. Against Southeast Asian militaries that lack equivalents, its presence alone would serve as a deterrent, reinforcing China's territorial assertions without requiring fixed-wing aircraft to leave hardened bases. Ultimately, the Z-21 is not just a helicopter, it is a signal. It tells the world that China no longer sees itself as a student of military technology, but as a peer competitor in its own right. It embodies the philosophy articulated by PLA strategists. Fight informatized wars with intelligentized systems. In this vision, machines like the Z-21 are stepping stones toward a battlefield where manned, unmanned, and autonomous platforms blur into a seamless web of sensors and shooters. The psychological impact of such a system cannot be ignored. For domestic audiences, state media will portray the Z-21 as proof of China's inevitable rise, a dragon now armored with steel and composite. For adversaries, every unveiled image of its angular canopy and cheek-mounted fairings will be a reminder that the PLA is closing gaps once considered unbridgeable. For arms buyers in the developing world, the Z-21 is the embodiment of an alternative to Western dependency, a herald of a multipolar arms market. The Z-21 is not the end of China's journey in rotorcraft, but rather its beginning. Future variants will almost certainly experiment with more powerful turboshafts, stealth-enhanced fuselages, and unmanned teaming capabilities. It is plausible that within a decade, a Z-21 could control drone wingmen, small, expendable rotorcraft carrying additional sensors or missile pods, mirroring the loyal wingman concept unfolding in the fixed-wing domain. Likewise, navalized variants could emerge, optimized for operations from carriers or larger amphibious vessels. In this sense, the Z-21 is less a singular product than a modular platform, an airframe onto which successive waves of technology can be bolted. Its initial entry into service will mark the close of one chapter, the pursuit of parity, and the opening of another, the pursuit of qualitative advantage. The AVIC Z-21 thus stands as more than a war machine. It is a declaration that China's military-industrial complex has matured into a force capable of producing the symbols of great power status. Where once the world's apex predators of the sky wore stars and stripes, or the Red Star of Russia, they may soon also bear the 5 stars of China's red flag. The helicopter itself may one day be superseded by drones, AI-driven platforms, or technologies not yet imagined. But for the coming decades, the Z-21 will prowl the skies as both weapon and message. That the balance of power in the 21st century will be contested not only at sea and in cyberspace, but also in the beating rotor wash of a new dragon's wings.